Welcome to the 45th lecture. So, we have been discussing about the gyroscope. So, actually our ultimate aim is to get into the reaction wheels and control moment gyros. So, control moment gyros are used for controlling the attitude of the spacecraft or the satellite, while the gyroscope itself, it is a device which can be used for measuring the angular displacement and then the angular rates. So, in that context, we have been trying to, before going into the entering into the reaction wheels and the control moment gyros, we are trying to enter into this gyroscope. How does it work? And already we have looked into the rigid body dynamics of a cylinder, which was a symmetrical case. It can be unsymmetrical also, but here the gyroscope, it consists of two frames, as we have discussed earlier, that it consists of two frames, one the outer frame and the another will be the inner frame, which we have. So, this is on the gimbal here, and then you have another frame which is inside this, and then we have another frame. Then there is a wheel attached to this, and this is also a gimbal. So, these are the gimbal points. So, why we were discussing that we wanted to look into the behavior of the system, which is nothing but a top, playing top. So, it is pivoted here about with a ball socket joint, and then it is displaced from the vertical by theta angle and spinning about this by angle phi, and then we draw it we drew it on the right hand side the last time. It does not matter whether it is on the right hand or the left hand side. So, to understand the behavior of this system, we were looking into this, because this system and this system, they do not differ much. Here, if we assume this to be massless, these two frames we are assuming to be massless, and therefore, this moment of inertia, it is getting ignored and we are just concentrating on this wheel. So, this wheel will be have rotation because of the rotation about this axis, because of rotation about this axis. So, it is a anti-clockwise rotation here. So, theta dot here we have written, psi dot here, and then it is rotating on this axis itself, spinning. So, which we have written as phi dot. So, overall the behavior of this system, it will appear to be the same as the behavior of this system. So, behavior of this system means without the frame mass, these two frames are this and these two frames, they are massless. So, understanding this, it will help me in solving this particular problem, and here we, instead of taking the reference frame at the center of mass, I can choose the reference frame here in this place, and we can write here as x, y, and this is the z axis, and we know that this is spinning here, spinning on this axis as it is shown by this arrow. But as in the gyroscope last time we have discussed that this x axis which is here and the y axis which is going here in this direction and the small z axis which is here. So, this is not spinning along with the disc. Similarly, here in this case this x and y, they are not spinning along with this one, but it is a nutating, and this axis is nutating and this axis is also precessing, and this is because of the symmetry. So, in that context we derived certain equations, and those equations, once we use it, so it will give us the result we are looking for. So, we derived the total moment acting about the x axis. So, this was minus I times psi double dot sin theta So, this was one of the equation. The second equation we have written. Okay. Now, let us consider a very simplified situation before we go into the actual problem. Okay. So, in the simplified problem, what we are looking for, that the under what condition theta dot will be 0, means theta is a constant, psi dot this is a constant, and phi dot this is also a constant. So, we have to find out the torque condition basically from this. So, let us explore this. So, if we look here in the first equation, so if your theta is constant, so this implies theta dot this will be 0, and also theta double dot this will also be 0, because it is a constant all the time. So, you can look that, because theta dot is present here and theta dot is also present here. So, this term will drop out, this is dot here. So, this term will drop out, and okay, this term drops out and this term also drops out, leaving out only the first term. That means, E m x will be equal to minus I times psi double dot sin theta. So, this term is going out, because of theta dot equal to 0, this term also gets deleted. If we look here in this part, so E m z, this quantity I 0 d by dt phi dot psi dot. So, here as per our original problem, we wanted to solve this problem. So, along this axis no moment is acting, this is the vertical axis, we have written this as the capital Z axis. So, this is capital X, this is capital Y, and with respect to this your x, y and z from, if your this cone is on the right hand side. So, we can show it like this, this is the small z axis and the x and the y axis is here, small x and small y axis. This angle is theta. So, with the vertical, this x axis also that makes angle theta. So, we get one equation here. If we look here in this, so from there we will have E m y. Now, again okay, one more thing, here psi double dot, this is also 0, psi dot is constant, because this condition we have not yet taken. Psi dot is constant, we are assuming here a simplified problem. So, psi dot is constant and phi dot is also a constant. So, that means this term should also vanish. So, that means this simply implies, so from here we can write on this side, this implies psi double dot this equal to 0, this implies theta dot equal to 0 and theta double dot this is also 0, and this implies phi double dot this will be equal to 0. So, therefore, in the first equation all the terms they drop out. So, this becomes simply 0. Thereafter, we pick up the second equation, here theta double dot this will be 0, but this term is not 0, and here if we see all these terms are present. Okay. So, this becomes I times minus sign we will have to put here minus I times psi dot square sin theta cos theta sin theta cos theta, and then from this place I 0 psi dot Okay. Now, here in this part if we look, phi dot is a constant, okay. Psi dot is a constant as shown here, psi dot is a constant, phi dot is a constant, and theta is also a constant as per our assumption. So, this part, so this implies that phi dot plus psi dot cos theta, this is also a constant, and therefore, derivative time derivative of this will be 0. So, this implies E m z, this is also 0. So, the condition we were looking for, that phi dot equal to a constant and psi dot this is equal to a constant and theta this is equal to a constant, leads to the condition that E m x this should be 0 and E m z this should also be equal to 0, and what is non-zero is E m y, and that E m y is written here in this place. This is the net torque on the along the y axis minus I times psi dot square. So, we will take it on the next page, minus I times psi dot square sin theta into cos theta, sin theta into cos theta plus I 0 psi dot sin theta plus I 0 psi dot sin theta and times phi dot plus psi dot cos theta, okay, this particular part. We can rearrange it. Okay. So, from here then we get the desired solution. Okay. So, our solution will be E m y, means the what is required, that torque along x axis should be 0. Remember, this is the body axis which is nutating and precessing x axis. So, here in this case, because theta dot equal to 0, okay, theta is a constant. So, no nutation rate, but nutation angle is present, okay. And this is torque along the z axis, all these are the body axis. Okay. So, if we rearrange it, so we can write here as this quantity is nothing but your omega z. Okay. So, we can write it in a simple way, I 0 times psi dot omega z times sin theta minus I times psi dot square sin theta into cos theta. So, this is the amount of torque required. You can see that theta is a constant here, okay. Only psi dot and phi dot which has gone into this omega z. So, phi dot, these two quantities are present. Okay. Now, we can do little bit more simplification to this. Let us assume that E m y is also 0. Okay. One more condition we impose, already the 3 conditions we have imposed, and one more condition we are imposing, E m y is 0. So, what does this mean? Already you have no torque along the x axis, no torque along the z axis, no torque along the y axis. So, then this gets simplified to a situation we have been discussing for the rigid body dynamics, which is torque free rotational motion of the rigid body. Okay. This problem we have already discussed. So, let us look into this problem psi dot square sin theta into cos theta. We will separate out the phi dot term, okay, and psi dot term, and write the equation correspondingly. So, this is I 0 psi dot square sin theta cos theta psi dot square sin theta cos theta plus I 0 psi dot phi dot sin theta, on the right hand side sin theta times cos theta. And what we are interested in, let us first take psi dot on the these terms we are going to rearrange. Okay. So, we will write this as I 0 psi dot phi dot sin theta, this equal to I minus I 0 psi dot square sin theta into cos theta. Okay, because psi dot is non-zero, psi dot this quantity is non-zero, okay. And theta also, the theta which is present here. So, this is on the both hand side. Okay. So, theta is non-zero. So, in that case we can put it like this times I 0 times phi dot, this equal to I minus I 0 psi dot cos theta. So, this implies psi dot equal to I 0 divided by I minus I 0 times phi dot divided by cos theta. Means the equation we have got here, this is psi dot equal to I 0 divided by I minus I 0 and this is exactly the expression we got for the three body so, what we have got for the torque free rotational dynamics of a cylinder or either disc Okay, so, through this route also what we are getting, that the same result for the rotational motion of a cylinder or a disc which is free from torque, you will get psi dot equal to this quantity, the expression which is written here, which we are getting through some indirect route. Okay. So, the same problem it can be solved in multiple ways. Now, we are interested in that if we spare it that E m y is not equal to 0. So, in that case only, and these conditions they apply. So, we will have to apply this much of torque along the y axis to maintain the motion. Okay. So, to maintain the motion, with theta dot equal to 0 or theta equal to a constant, and psi dot this is a constant, and phi dot also this is a constant. So, under this assumption what we are getting m x equal to 0, m z equal to 0 and m y is given by this expression which is written here in this place. So, I 0 times psi dot omega z, psi dot omega z is phi dot plus psi dot cos theta, this part and then sin multiplied by sin theta minus I dot I times psi dot square sin theta cos theta, psi dot square sin theta cos theta. Now, let us look into a limiting case. If theta equal to 90 degree, okay, so in that case what result we get? Okay, so for theta equal to 90 degree, cos theta will be equal to 0 and sin theta is equal to 1. Okay, so we get m y equal to I 0 times psi dot times phi dot, this part will be 0, sin theta becomes equal to 1. So, on the other part we have I times psi dot sin theta is 1, but cos theta becomes 0. So, this part other part is also 0. So, what we get I 0 psi dot times phi dot. So, when the disk of the gyro is making theta equal to 90 degree. So, at that time the torque required to maintain the motion along the y axis will be given by I 0 psi dot phi dot. Now, we are ready to take the original problem. We wanted to discuss about this problem. Okay. So, now we are in a position that we can discuss about this problem. So, this way you need to analyze all the problems. So, for our present case, okay, there are few more things before we go into that we will discuss about. So, your omega is minus psi dot sin theta times theta dot, see omega the equation, it is a long equation we have written. So, under the assumption that theta dot this equal to 0 and psi dot this is a constant and phi dot this is also a constant. So, I am exploring the same issue from the other perspective, and it is important that we take care of all these things, and basically we are trying to learn here. Okay. So, we should look into all the angles. Okay. So, we should look through all the angles. So, here we have the omega we have written earlier, derived one particular equation which is omega equal to minus psi dot sin theta I cap plus theta times j cap So, when your theta dot equal to 0, okay, here this is theta dot. So, this term will drop out. So, this term becomes 0 and omega gets reduced to minus psi dot sin theta I cap plus theta dot j cap, this part is gone, plus phi dot plus psi dot cos theta times k cap. This is omega, and similarly the H 0 vector, then what we have written earlier. So, that gets reduced to H 0 we have written as minus I times psi dot sin theta times I cap plus I 0 times, basically multiplying this by I and this. So, here because theta dot is 0. So, this particular j term will drop out here also. So, what we get here I times psi dot sin theta times I cap plus I 0 phi dot plus psi dot cos theta times k cap. Okay. And there are few other things that we also need to look into. Okay. And capital omega, this term is minus psi dot sin theta I cap plus psi dot cos theta k cap. Capital omega we have written by the equation minus sin dot, there was one more term which was theta dot times j cap. So, this term, this drops out because of this condition, and we get only this term. So, this is your angular velocity of the frame, okay, not the angular velocity of the disc. This is the angular velocity of the frame, and this is the angular velocity of the disc or the cylinder. Cylinder slash disc. Okay. If we look for the momentum component along the capital Z axis, so what we need to do, just we need to take the dot product of this with respect to capital K, and that will give you the momentum component along the Z axis. Okay, so, few more things we can write here. If you look here in this equation, the angular momentum equation, I is a constant, psi dot is a constant, theta is a constant, I 0 is a constant, phi dot this is a constant, all these are constant. Therefore, this implies that H 0 magnitude, this is also going to be a constant. Okay. What else we can do here further? This also implies we have I dot sin theta, this is a constant, and already we have written I 0 times omega z, which is equal to phi dot plus psi dot cos theta, this is also a constant. Okay. Therefore, dH0 by dt with respect to the body axis. Okay. So, your H vector is constant and therefore, this quantity this becomes 0. So, what is left in the equation E m, this we have written as dH0 by dt with respect to the body axis plus capital omega cross H 0. So, here this part this drops out under the condition we have mentioned, where theta is a constant, phi dot is a constant and psi dot is also a constant. Okay. So, you see that the situation gets simplified to capital omega cross H 0. Okay. Moreover, in this problem, where the cone is tilted like this axis is making theta angle with this one, and here your x axis and y axis are directed. This is capital X, capital Y, capital Z. This is a small z here. So, we can see from this place that E capital M Z, this quantity is 0, because your m g this is acting just downward. Okay. There is a torque about this axis. So, if we assume that the situation is something like this is the z axis and x axis is going down like this. Okay. So, with respect to this capital Z axis, the small z axis is tilted, and with the horizontal, then your x axis is making angle theta. Okay. So, under that situation you can see somewhere on this, somewhere m g force is acting, and because of that you get a torque here in this place. So, this torque will be directed along the y axis, which is going inside the plane of the paper. Okay. So, this quantity is 0. Similarly, we do not have torque along this axis. So, here no torque, along this axis also no torque. Okay. So, the torque is acting along the y axis. So, E m small z, this quantity also is 0, and you can solve for this. So, if we try to work it out, so E m z, this equation we have written as I 0 d by dt phi dot plus psi dot cos theta. So, if this quantity is 0 from this place, this particular one, this is along the z body axis. So, this implies that phi dot plus psi dot cos theta, this will be a constant. And let us assume that phi plus psi dot cos theta, this quantity we write as, we can give some name to this. Let us say this we write as beta. So, this is the one relationship we are having. This simply says that along the z axis, your component of angular velocity along the z axis, this remains constant. This is simply it implies. So, component of angular velocity along the z axis is constant. So, it is not changing. Okay, so, we will continue looking into this particular topic. Still lot more has to be done. So, we will continue in the next lecture. Thank you very much.